All right, so in this video, we're going to go through sample question 30 from the Society of Actuaries ExamP list of sample questions. So the question reads, an actuary has discovered that policyholders are 3 times as likely to file 2 claims as to file 4 claims. The number of claims filed has a Poisson distribution. We need to calculate the variance of the number of claims filed. Okay, so this is another example of just you memorize the distribution, you understand how it works, a problem virtually solves itself. So let's first deal with the first sentence. It's discovered that policyholders are 3 times as likely to file 2 claims as to file 4 claims. Okay, so the probability that you file 2 claims, that x equals 2, is equal to 3 times the probability that somebody files 4 claims, that x equals 4. Now, we're told that this probability distribution of how many claims filed is a Poisson random variable. And the probability equation for a Poisson random variable is the following: e to the negative lambda times lambda to the x over x factorial. Okay, and we're asked to calculate the variance. And what's really nice about a Poisson random variable is that the expected value is lambda and the variance is also lambda. Okay, so let's go back calculating this. Right, so the probability that x equals 2 should be the following, because what we're essentially trying to do is use this to calculate lambda. All right, I'll just draw a little border here so that doesn't get confused. So the probability that x equals 2, e to the negative lambda multiplied by lambda to the x power, which is 2, over 2 factorial, equal to 3 multiplied by the fraction e to the negative lambda multiplied by x to the 4th over 4 factorial. Now, what you'll notice is a lot of things can start canceling out eventually. Like immediately, if I divide e to the negative lambda to both sides, that cancels. Right? If I divide lambda squared to both sides, this cancels. And this will become a lambda to the 2nd. So now let me rewrite what I have. So look, what I left here is 1 over 2 factorial is just 2 times 1. That's easy. Here I have 3 times lambda squared over 4 factorial, which is 4 times 3 times 2 times 1. Now these 3's can cancel. Multiplying 2 to both sides, those cancel. And then I'm left with 1 equals lambda squared over 4 times 1 is 4. And hopefully I don't really need to explain this next part much, but I eventually get lambda equaling 2. Okay, now the variance is what we're being asked to look for. Calculate the variance. Well, the variance should just be lambda, leaving us with answer choice D. Okay, so this question, if you know just the probability function for a Poisson random variable, super easy. No probability needed. This is an algebra question. Right? So I can't stress enough how important it is to be very familiar with how those work, know those equations. One thing I will say is, in terms of discrete probability distributions, Poisson binomial, most frequently to occur. Uniform occurs frequently, but more so in the continuous case than the discrete case. Typically, those kind of things occur when it's like you have a policy with a deductible and the loss is uniformly distributed or something like that. However, for a Poisson random variable, sometimes you need to kind of figure out that a particular random variable, follows a binomial distribution or something like that. They will normally tell you when something is when something has a Poisson distribution, right? That's very rarely something you need to figure out on your own for this exam. But that's pretty much it. I mean, if there are any questions, you can leave it down in the comments. I'll answer them to the best of my abilities. If you want to see more worked out problems, I got a playlist. And hopefully this video helped you out. And if it did, hit the like button, subscribe, because that definitely helps me out. But other than that, good luck, guys.